All right, class, let's start here. Let me back up here. This is Trig homework 7.3. We've got 21 and 25 to do. So we go with trigonometry number 21, and I already set this up here. This is two airplanes, one flying 130 miles per hour and another one flying 150 miles per hour. Let me check that, make sure I got the numbers right. And there's a 36-degree angle between them. Yeah, 150, okay. Okay, and so we want to know what is the distance between them. So I got this guy. That's what we're trying to find out. But now the question is, if it's flying 130 miles per hour, we're trying to figure out when it is after 1.5 hours. So get our calculator. We're going to go 130. Well, let's turn it on first. Boom. There you go. 130 times 1.5. We can do the other one as well here. 150 times 1.5. So we get all that right there. So I got 195 and 225. Okay, 195, got 225 miles. That's how much that is. And then we need a connection between this piece here. Let's label this as A, B, C. We need a connection to little a right over here. And yes, we do have that connection. It's called the law of cosines. So let's jam with it. So we got a law of cosines based upon little a. So let's do the formula for it first. There's that. I think it's b squared plus c squared minus 2 times bc cosine of angle A. So let's put that together. All right, putting in the numbers here. Let me flip between charts here, or I can maybe put it in like this real quick. All right, I'm going to go with, let's see, I'm going to go back over here. Let's see, I got, that's B. So B is going to be our 195. Our little c is going to be 225. So 195 plus 225 minus 2 times 195. Oof, that's, can't really see it that well. 195, 225, cosine of 36 degrees. Okay, let's punch that into the calculator and let's see what we get. So with these calculators, you can punch in the whole thing, so that's kind of nice. It's 195 to the second power plus to a second power minus 2 times 195 times 225 times cosine of 36, and I just got to make sure I am in degree mode. So let me click on mode. I am in degree mode, perfect. And I go with that right there. Okay, and then don't forget this is not a, right? This is a squared, so I'm going to have to take the square root of my answer. So we're going to go with, let's see if I did something wrong here. I feel like something's off. Yep, there it is. I feel like it was too small here. So notice it was 2 times 95 times 25. Not good, not good. So if you ever want to come back to this right here, I'm going to click entry. Look at that. It gives me back my entry again. So not 25. How about, oh, then I have to insert the 2 here. So I'm going to go second, insert 2. Whoa, that's cool. There it is, 225, so I don't have to write it all over again. Click. Much better. There it is. Okay. And then we're going to take the square root, boom, of our answer. So we jump to here, close it off, enter, and there it is, 132, so 133 miles. 133 miles. Now the book most likely is going to give you 130 miles because you're given, notice, 2 decimal place accuracy, or 2 significant digits of 130 and 150. Those are 2 significant digits. Therefore, if you think about it, should be this. Okay, but I'll accept both. That's correct. That's correct. That's fine. All right, number 25. It's a vector problem. Okay, vector problem says this. Let me draw it out as well. I got myself due north right here. That's the way we do these guys. I change pin color here, and let me read the problem. 25. A plane is flying airspeed of 160 miles an hour, heading 150 degrees. So this is 180. So that means this plane is going like this. And we kind of put 160 right over here. Okay, it says the wind currents are running at 35 miles per hour at 165 degrees. Okay, let me change the color on this little guy. So wind currents are actually more. They're more closer to 180 than that. So I'm going to go like this. And I'm going to go like that. So I should have labeled the other one here. So this would be 165. And this one is going to be 150 for this guy. And I should put a little round right here, 150. Okay. All right, let's go with it. How's this going to work out? So we have somehow we have to move things around so we get both of those connected, and it's called end to beginning, right? Or head to tail, however you want it. You can slide this down this way. So I'm going to I'm going to slide this arrow here. I'm going to slide it down to here. So let's see if this works. I'm going to keep the red arrow. Let me keep the colors exactly the same too here. So I'm going to keep this guy like this, and I'm going to move the plane. This slides down, and now it's like this. Okay, so now we need to figure this out. Okay, so here's our little problem. So then we got a third one. So I think this is probably the most difficult part of it. And here's your true course. True course is that right there. So you got an airplane took off, it's flying this way, and the wind is pushing it a little bit further to the east. That's kind of what we have. So we've got to find these angles here. That's our little problem. Okay, so let's looking at this here. If that's the case, I'm going to put it like a north side. Let's see if this helps a little bit here. So I have this little guy here, going like this, like that. Let's see if that'll help a little bit here. Okay, we kind of knew that this part was right here. Let me make this into a different color altogether here. Let's go with the dark blue one here. So we know that the angle here was 15 degrees. It's 65 minus 165 minus 150. So we know that this technically right here is still a 15-degree angle. Right? When you slide angles down, we don't change the angle. So we know actually this guy, then this guy is going to be 180 minus 65. Angle between them. So this is 165 right here. That's cool. Good there. All right. And is that all I need? Kind of thinking here. Oh yeah, hold on. So this guy's still out traveling 160. This guy's still traveling at 35, which I didn't put over here. This was 35. I kind of extended it out. Should have been a lot shorter. Oh yeah, law of cosines, right? I have my two sides and I have my angle in the middle. And I am good to go. So let's go for it. So I'm going to label this again. So I'm going to label this as A, B, C. So what we need to do is we need to find little b this time. So let's go with b squared is equal to AC plus minus 2AC cosine of b. All right, plugging in. I got myself, let's see, what do we got here? So A is C, I'm sorry, C is 35. Little a is 160. So I got myself 160 squared 35 squared minus 2 times 160 times 35 cosine of 165 degrees. Okay, punching that into a calculator. Let's see what we got. 160 squared plus 35 squared minus 2 times 160. I'm going to make sure I do this correctly this time. 65. Okay, so let's do that. Okay, then remember we still have to take a square root of that. So we go with Square root of our answer. Close it off. Boom. Okay, we have an airspeed of 194 miles per hour. That's what we're looking at there. Okay, and then we've got to figure out the angle. So how do we figure out the angle between them? Okay, so let's see. Let's see, angle between them. I got this. I know, let's see, I know this right here to be 15. True, true. No, that's not 15. That's not going to happen there. Okay, kind of thinking through this here. Okay, well, I know the law of sines, right? So I don't know this angle is. Angle A is going to be over 160. Oh, cool, law of sines. Let's do that. So let's go back to this little triangle here. So we have this triangle. It's going like this right here, right? We know this to be 160. We know this to be 165. We know that to be 35. And we know this to be what did we get? 194. Okay, so notice we have an angle. It's opposite side. And then I want to know this angle right here. That's what I want to know. So I'm going to go sine of 165 over 194 over sine of, oh, let me get my bearing straight as ABC. ABC, and what I'm trying to do is angle A over 160. So multiply that out. 160 is on top here. 65 over 194 is equal to sine of A. Therefore, we're looking for an angle measurement of that. Sine inverse sine of 160 of sine 165 over 194. And we're going to see what the sine value is. Let's go with it here. So sine inverse of, let's see, so 160. So notice I'm not going to change this to a fraction. I don't need extra parentheses because I just have one single number on the bottom. So this is 160 sine of 165. Close off that one. Divide by 194. Now, if you are off just by a little bit here, that's still okay. So I got 12.3. I'm going to go with 12. So this guy now is 12 degrees. Okay, so remember originally, if we go back over here, remember this was 165. So now we have it's 165 minus the 12. That's what we have. So originally, because what we did is we kept the red arrow right on our grid system. So everything is controlled from there. So if that's 12 degrees, technically it's just 165 minus 12, and we'll get what we need. So 165 minus 12. If you guys do that in your head, I almost messed up. All right, we have bearing, right? So we have true course. Is, and let's see how we write it in the back here. So wind is flying, okay. So true course is 194 miles per hour. Bearing, okay, I'll write it a little better. True course. Oh no, it's heading, so that's right. Hold on. All right, let me write it. So the plane flying at airspeed, so the true course of the airplane is 194 miles per hour and heading oh, okay, the true course is and heading 153. Sometimes it's called bearings, I'm not sure. But anyways, we are done there. So there's your two answers here. So there's that, and there's your